Hi everyone, welcome to Microsoft Build 2017. My name is William Bloom. I'm here with Marina Polishuk.
Hi everyone.
We're from the Microsoft Security Risk Detection team, and today we're going to tell you more about the service, how it works under the hood, what it is used for, and how can you use it to test security vulnerability, to find security vulnerability in your code. And so we're just going to give you a 200-level overview of the service. It's not going to require any security testing expertise, but we do want to warn you that some software development background could be helpful for you to understand some of the concepts we're going to talk about. And so this service, Security Risk Detection, is a security detection tool, so it helps you find vulnerability in your code. And we have a great story to tell you about how can this be helpful. And so Marina joined the team recently. She has a great story to tell about how she got involved with security.
Yeah, so on my previous team, this was a few years ago, I was working on a feature, and for the first time I had to do some fuzzing.
And so what were you looking for really at the time? Like what type of tool were you looking for to help you find vulnerabilities in your code?
Well, so the reason I had to do fuzzing was kind of twofold. First, fuzzing in general, we mandate in the security development lifecycle, which is a set of best practices and a workflow that we use at Microsoft to make sure we build the best secure software that we possibly can. And in addition, for my particular case, I was introducing a new internal format that was used in a protocol in the product, which was also shipped as a service. And this could have denial of service implications. So this was why this was flagged for me to make sure that the input parsing was very robust and could withstand potential denial of service attacks.
And so like here we're looking at the workflow that's used by Springfield for a customer to use the service. So could you explain how this particular workflow would have helped you and your previous team to find those
Absolutely.
vulnerabilities?
So one problem I had in the work, this was a few years ago, but still by that point, Microsoft had done a lot of very sophisticated development of fuzzers and fuzzing on various teams. However, in my particular scenario, it was a slightly different architecture that I was using that didn't fit well with existing fuzzing infrastructure on my team or others at Microsoft in particular. And what I had to do was basically figure out how do I pull in these advanced fuzzers into our infrastructure and our lab and be able to actually have the test capacity that I needed to do like repeatable testing of this for this fuzzing criteria. So it wasn't just something I could do one-off on my dev box and just make that one-time investment. It was going to have to be a regular kind of thing. So really what I was looking for was for a way to just take the binaries that I was producing, maybe from the latest build, and submit them to a system that would fuzz them effectively and actually just give me failures that I could then go and look at and fix my bugs rather than spend, as we all know, spend all this time configuring infrastructure just to make it work for you for a very basic case.
Okay, so this is actually what we see here on the diagram. So the workflow when you use the service is you come with a set of binaries or application that you want to test. You connect to a service, you upload your binaries. Then on the second step, we run multiple fuzzers that we have in the background. We run security testing on those binaries. And then we identify some bugs, we classify them, we report them back to you. And then you get an opportunity to fix them and then try again to submit to the service until you get clean. And so maybe it's time to give a quick demo on how this works actually in practice. And so what you see here is a list of jobs that we have created before. And every job actually corresponds to a unit of work that you want to fuzz or to test in a service. It could be multiple iteration. Every job could be one iteration of the same binary, or it could be separate binaries or separate application that you want to test. And so you can create jobs. So here, if you create a job using the Create Job button, a new entry will be created. But you can see also that for pre-existing jobs, we have some details about the particular operating system that we provision. And we also give you access to the VM And so we give you access to an RDP file that you use to connect to the remote desktop connection protocol. So here I've already have connected to a VM. So I'm going to show you how it works. So suppose you want to test an application like, for instance, Word, let's say. Well, you would connect to that VM, you will install Office on the machine, and all the dependencies that you want to test, if you have extension that you want to test. And then we're going to guide you through the submission of your job using the wizard. So this wizard first asks you about which executable you want to fuzz. And so here I've pre-installed some example on the machine. And so we can take a look at, say, demo fuzz. That's a sample application that I've installed on the machine. I just go through a few questions about that particular job. The next piece of information we want to give is a set of what we call seed files. And so seed files are example of input files that your program can take as input. And so for a Word, if you were testing Word or for any other word parser, that would be a bunch of Word documents that we will use as a sample when we fuzz and try to create new files that will trigger crashes. And so here I've provided an example on the VM under the data directory. I click next. We ask a few questions about the runtime behavior of your program. If you want to know more detail, actually, it's a good moment to refer you to the Learn to Fuzz, How to Fuzz video by David Molnar. And so you can take a look on channel 9. And so let's click next here. I validated the job just to make sure that everything is going to go smoothly during the submission to the service. So we actually here run your executable and make sure that there is no error during execution. And now we're good to go and we can submit. And so it takes a few minutes to capture the VM. At this point, we validate that everything works. And when we decide that it's good to go, we provision what we call the fuzzing lab. And so what happened is here, for those jobs that you see that were already submitted before, you see that they've been submitted some time ago, so they've been fuzzing already for some time. And let's take a look at what type of results that we found for this job. If I click on results here, I see two buckets representing two types of bugs that we find in the code. One of them is first chance exception, another one is a crash. So I can click on detail here, and that will give me some information about the input that were generated to trigger this crash. But also we include logs from WinDBG, the Windows debugger, about what happened during the crash, which module were loaded, what was the actual error code, and what is the call stack. And so, so this gives you a brief overview of how you actually use the service. And I think it's maybe a good time for us to tell about what type of results and what type of bug we found in the service. So let me switch back to the PowerPoint here. And Marina, maybe you can tell us more about the type of vulnerabilities that we can detect with Springfield.
Yeah, sure. So one of the things that can happen, for those of you who have done fuzzing in the past, is the first time you fuzz something, you may get back like hundreds or thousands of different failures. And so prioritization becomes pretty important. And as William mentioned, we already help you bucketize the failures. So we're continuously improving in that area, trying to make sure that you're really analyzing only the unique issues. And we also do some lightweight prioritization for you. Ultimately, you're going to be the one with your own bug bar deciding whether or not to fix these issues. But we kind of help you classify it according to the standard practices of what different types of vulnerabilities typically correspond to for the type of failures that we detect in our service. So what you're seeing on the slide is a sampling of failures that we recently found in production.
And so typically what type of issues here you would want to address? You see a bunch of different crashes and first chance exception. As a developer, what should I focus on?
Right, so as a developer, if you have no security expertise, there are certain issues that are known to very likely cause a possible elevation of privilege, such as a crash that's a right access violation. There are others that are less likely, but still may be possible. And this is where you may still want to fix them, or you may want to get a security expert involved who's going to take a closer look at the failures and really evaluate if an exploit is possible to build using that failure. And if you're running a service, really any unhandled exception could potentially cause, depending on your scenario, a denial of service. So for that earlier story that I told in my particular, even though it was an internal data format, so really it wasn't like an attacker could fuzz those specific input files, it was still a denial of service concern because by the service behaving a certain way, you could cause it to go into a bad state potentially and just not be able to serve any customers. And then just as a note, so even if the failure doesn't fit into those two buckets, we still give you the opportunity to review it and see if you want to fix it. And this allows some other use cases that are maybe not the first ones that you think of when you think of fuzzing, but for example, you may want to fuzz on a debug build to see what assertions are hit, because you want to be really confident that your assertions are something that are truly an assertion of things that should never happen.
And something I forgot to mention is that you can actually download those fuzzing inputs that we generated that can trigger crashes. And so you can reproduce those on your local machine. And you also mentioned that those are high-quality bugs that we submit to you. Those ones, we actually repro them on separate machines just to make sure that they are reproducible and they are not flaky bugs that you will see intermittently. So maybe now we can take a look at what happens in the backend. So we talked about the fuzzing lab. So what does it mean? Fuzzing lab is the set of machines that we provision in the backend for you. And so let me go back to demo mode and show you the Azure portal where we actually run the service. So here, what you're looking at is the actual Microsoft Azure portal that we use to run the Microsoft Security Risk Detection. And what you see here on the top left square, is a list of fuzzing resource groups in Azure that host the fuzzing lab that we provision for specific jobs. And on the right here, you see, let me zoom, here it's probably better. So you have a list of all the fuzzing machine that we've provisioned on that particular fuzzing lab. And so here we use that website to monitor that everything is going fine. For instance, here we can see there's a high CPU usage on 3 fuzzing machines that I've selected randomly here. And so this is very useful tool for us to see what's going on, but it also gives us the ability to scale because all those machines are actually provisioned in Azure. And so I think that this is a good time probably to talk about, if you look at the specific VM, you may wonder what actually run on that VM. So we talk about the results that we produce, but what is actually happening on those VMs? So maybe let's take a look. Let's go back to PowerPoint and let's see what happened on the VM.
Sure. So at a high level, it's useful to think about diversifying the actual type of fuzzers that are running. This is a strategy that was validated by many experiments. One in particular was a study done by Jason Shark in 2008. It's published. You can go take a look at it online, where they did kind of a fuzzing Olympics in the trustworthy computing group and found that using several very different fuzzers finds many issues that are unique to a particular fuzzer, and of course there's going to be some overlap. So it's a good idea to kind of diversify and also learn from the data and constantly improve the fuzzing mix. And in fact, we did this early on. We had a particular customer where they submitted an application, and it just happened that for the code patterns that binary had, actually none of our fuzzers found the bug. So we had to add another fuzzer. We kind of investigated what would be a good strategy, and we added it, and we actually were able to find bugs. So this is the kind of thing that we're continuously doing in the service, and it's kind of a great thing that maybe you wouldn't have time to do if you were trying to do this on your own.
And another thing is we support 2 types of fuzzers, black box and white box fuzzers, so maybe you could explain what it is.
Sure. So at a high level, fuzzing is, you're throwing invalid inputs into your application to try to see if you can break it. One way to do that is to not know anything about the application. Just take the examples that someone tells you, like as William mentioned, this is a valid Word file, and try to see if you can mutate them, or maybe if you can just generate junk files that you pretend are Word files and you feed them to the application and see if it fails. And this can be very, very effective. But after a while, once you fix all those issues, there's a certain depth that you can get to with those techniques, and it's very difficult to get past that. So we also use a technology called SAGE, which is white box fuzzing, which actually allows you to monitor the application as it's running. So you need some knowledge of how to monitor the application and understand, given a particular input, what paths were executed, and then try to learn from that to generate new inputs that will explore other, like previously uncovered branches or code or whatever your metric is that you're using.
So you talk about SAGE, so SAGE fits in which category? Is it black box or white box?
It's very much on the white box category.
Okay.
So SAGE is actually monitoring every instruction in your program, and it's doing what's called symbolic execution, and it's generating a constraint for the particular execution that you can then evaluate to generate new inputs that precisely drive it down on branches that you haven't previously executed.
And so we have a demo for this, but before we start, I just wanted to ask you a precision. So we say it's white box fuzzing. Maybe we want to clarify, what do we require from the customer to be able to fuzz?
Right, so typically, by definition in testing, white box means you kind of have awareness of the code in some way. So that may require source code, that may require symbols. In our case, we actually don't require any of that. So we work on binaries without symbols. They can be optimized in whichever way because we work at the x86 instruction level for this technique.
Okay, so maybe it's time to give a demo.
Sure. So as you can see, this is a clone of the VM that William showed earlier where you submit your job. It has the same submit to Springfield kind of application there. And if you were to look at this in a real context of our service running, you would see a program that's already executing here and fuzzing, but I've stopped that and I'm going to start it from scratch to show you what it would do. So in this example, this is a fairly simple example. It's a program that's reading an input file and storing it in a buffer, and then it's doing a few kind of tests based on the data in that buffer. And then if all of those branches were actually taken, there's a crash.
So here we see that we're testing for a very specific sequence of bytes in the file. We're testing for BAD exclamation mark, which is something that's very unlikely to occur if we were selecting files at random.
Yes, if you can imagine, it might take certainly millions, billions potentially of iterations to actually find this in a random fuzzing approach. Now, of course, there's heuristics you can use, but the idea is that it would still be difficult. And I will show you in this demo how SAGE can do it very, very quickly. So we mentioned earlier that there are seed files that we used, which are example files that should have pretty good coverage of your application that you give us that will then allow us to use as a basis for fuzzing. So here I'm going to show you the seed file that we're providing.
So maybe you cannot see it very clearly, but it's written GOOD. Thanks for zooming in.
So you can see that there are 4 bytes GOOD in this file. And as we saw, this is going to take the else branch for all of those, and so we're not going to crash. And now...
And that's a sample we will provide to Springfield, for instance.
Yep, absolutely. And now we will see what happens when you run SAGE. So if we monitor this directory where I've started it, you see that it's creating some directories with a GUID. Those are actually new inputs that it's going to generate based on taking an instruction trace, doing symbolic execution, generating constraints, and then solving those constraints using the Z3 constraint solver, which you can learn more about. We'll give you a few links, but it's a constraint solver that's been out in open source and industry used for many years, for many applications, not just fuzzing.
And so what is the output of SAGE?
And so we ran this for about 30 seconds. And look, there are some results. that are already there. And the other thing to note actually is Sage says that it's done. So this is like an interesting kind of philosophical question. Usually when is fuzzing done? But for small examples like this, Sage has truly explored the full tree of kind of possible branch combinations that are feasible to take in this program. So that's kind of one aspect that's fairly unique about Sage, is like for small programs, it's actually kind of like verification at that point. And as you can see, if we go to the results, there was a crash found. And if we look in the crash directory, we will give you the file that produced that crash. And if we zoom in here, we can see that it actually found that BAD exclamation point.
Right, so we just give it the example good, and it figure out how to find bad, which actually makes your application crash. So it's a very unique tool that we bundle in Springfield among other fuzzing technologies.
Yes, and one thing to note is, of course, this is a very small toy example, and there has been tremendous work done over a decade across many of the very complex parsers and other applications at Microsoft, in particular Windows and Office, where Sage was used and tuned and kind of developed to a point where it really works and scales for those large applications.
All right, great. And so we talked about security a lot, but we didn't mention about security of the service itself and of the data that we, of the customer data that we host on the service. So maybe we can give another demo here where we just want to show you how we actually provision a fuzzing lab in the backend and how we secure them in the backend of Springfield. And so the first thing I want to show you is that all the fuzzing lab VM that I showed you earlier, they all run in the same VNet environments, which means that in Azure we provision a virtual network for every job that you submit, whether they belong to the same customer or not. And so a machine on one VNet will not be able to talk to a machine on another VNet. So they are fully isolated. So if you connect to our fuzzing VM, and actually I can show you before I show that, if I actually show you from the portal the information about the VM, traditionally in Azure, you have a connect button that allows you to get access to that VM. In our case here, you see that the connect button is disabled. So which means that you actually don't have any entry point on that VM. So all the data that we store on that VM is secure. We did, for the sake of the demo, open a connection to one of the fuzzing VM here. And what I want to show you is that if you can actually connect to that VM itself is not connected to the internet. And so here, if I just want to show you a ping, for instance, so this is a website that's hosted by a separate cloud provider, and you can see that the connection times out. So we cannot ping it. You can try other websites like Microsoft.com. And here we go, same thing, we can get the IP address from the DNS lookup, but we cannot actually talk to that machine. So that's one aspect of security we wanted to talk about. The other aspect is about security settings that we baked in Springfield to make sure that we give you configuration settings for you to be able to control security of the VM that we give you access to. And so for this, I'm going to show you a small video that we recorded earlier. And that's going to show you how this all works. Let me grab that video. And so the idea is that some customers think about like large corporation that may have a lot of IP addresses. So for instance, you may have a range of IP address allocated to your employees. You want to make sure that the employees can only connect to those virtual machines that we provision for you from those IP addresses. And so I showed you earlier on how you can connect to a VM. And so we give you access to an RDP file. You see that the name that we provision, the name of the machine is at cloudapp.azure.com. So it's a VM that's hosted in Azure. And so you don't want every people on the internet to be able to access it, right? So here I was able to connect, the wizard starts, everything is fine. Now, one of our customers told us the feedback that it was not working very well for them. And so what we did is we added a feature in the setting page of Springfield where we let you configure the set of CIDR ranges of IP addresses that you want to allow on the service. And so if here, for instance, you remove that particular range, it takes a little while for Azure to apply the setting. And then if you go back to the original page, re-download the RDP file or even use a file that you previously downloaded on the service, if you actually try to connect to it, that connection will fail. And so if we wait a little bit, we're going to see how it works. I try to connect. It's initiating the remote connection, and in a few seconds, it's going to fail. And so this is one of the toggles that you can use to secure your VM. Another thing I want to show you is that we can control as well the set of port ranges that we use to set up the RDP connection for you. And so it's a well-known fact that a lot of hackers target the RDP port to try to brute force into to VMs in general that sit in the cloud. And so one thing you want to take care of is make sure that you use ports that are not the traditional default port 3389 used by RDP. And so here we have a setting that allows you to select a range of port numbers. And when we create a VM, we will pick at random any port in that range, and to make sure that nobody knows which one to try. And of course, the RDP file that you download has the right port that you would expect. All right, so that gives you an overview of the setting. If you want to know more about how we implement security in Azure, we would like to point you to the blog post from Azure about network security groups. They have great information about how you can use the same technology that we use to set up a VNet in Azure and configure your firewall rules as you desire.
So William, one other thing that customers really ask us a lot, I mean, we've covered quite a bit of sophisticated kind of under-the-hood technologies that we're using, but still many enterprises might want to further customize their own fuzzing efforts. And if this is really important, how should I decide if I should be building my own solution like this or if I should be buying?
That's right. And so, yes, you could build your own solution, but if you want to build it using hardware, that would cost you a lot. Here we build it using Azure, so we have the elasticity of the cloud, and we can scale using Azure. But also we provide to you all the orchestration around those VMs, so you don't have to to implement all that code that creates those VMs in the cloud. That's setting up the network interfaces, that's isolating them. And the other component is that we actually bundle unique technologies that are not available anywhere else. And so we have the right combination, as you mentioned about earlier, of fuzzers that would find the best bug that you could find. And so that's pretty unique. It's a unique feature of Microsoft risk detection tool.
Absolutely. And in addition, just like with any service that you can choose to use, you will get all of the support, and anything that goes wrong with any of the fuzzers or anything that's suboptimal, we will be constantly monitoring it and improving the service. So in particular, today for all the jobs, we record which fuzzer had the fastest time to the bugs, which fuzzer found the most bugs, and some of the uniqueness characteristics. And we can actually use that data, and we plan to use a lot of that type of data to further optimize if you resubmit the same applications to be tested on future iterations.
All right. Did we forget anything, Marina?
Yeah, I feel like we might be forgetting like maybe one thing we wanted to cover. I can't quite remember.
Oh, I think I know what it is.
Okay. Let's hear about it.
Yeah, so we talked about, it's just a tiny thing, but so we talked about how we can support Windows, right? But a lot of people have asked us about other platforms that we might want to support in Springfield. Well, we're glad to announce at Build that we're actually adding support for Linux. And so here we're going to demo how this works.
Awesome.
So here I'm connected on a different account. And so what you notice here is that you have two jobs already created, and in the operating system image column, it shows Linux Red Hat x64. And so if I create a new job here, I show you the new experience you get when you create a job on the tool. And so here you can select Linux Red Hat 7.2 and a job will be created for you. And so the question you may have here is, okay, so you show me how to RDP connect to a Windows VM. How do you do that on Linux? Well, on Linux, we use what's available on Linux, and traditional way people connect to a machine on Linux is through SSH. And so if I open the job here, instead of downloading an RDP file with the connection information to the remote session, I will instead get some connection information to the SSH server. So I will get a DNS name, username, and a password. So here, because I'm running on Windows 10, I will start bash on Windows, where I have a running version of SSH. And I will just get the connection string here, SSH customer at. It asks for the password. I'm just going to copy it from here. And here I'm logged in a Linux VM. So you can see it's truly a Linux VM. And we have a small message here that tells us, if you want to start a job with Springfield, just type sfwizard. So let's go ahead. And this is how the wizard looks like on Linux. So here is a small console interface you can access to from SSH that will ask you the same question that we showed you earlier in the wizard, but now in console mode. And so I'm not going to go through it because it's actually the exact same process that we went through on Windows. But what I want to show you is another job here that we started earlier, where we found some result. And if I drill down in the results, here I can see that we found 3 crashes with 3 different types on the Linux application.
Nice. And this is actually, again, a very similar application to what we showed you on Windows. And we use a very similar workflow. We have a blend of fuzzers, we have a failure detector and deduplication mechanism, and then we classify the failures.
All right, so maybe it's time to recap. So what have we learned so far? We demoed you Springfield. That used to be the name of the service, which is now called Microsoft Security Risk Detection. And we're gonna gonna give you some information and some things to follow up on. Maybe you want to talk about the sign-up page for the service, Marina?
So the number one thing that you should all go do, if you're interested in fuzzing or you're having to do some fuzzing or someone maybe already does it in your organization and you want to try to see how the Springfield experience is different or can help you in other ways than what you're doing today, please sign up. We have the Windows experience is something that we're actively onboarding. It's very stable and we have many customers already using it. And for Linux, we're now in preview and we're also taking preview signups, but that will be a slightly different process.
All right, and if you want to learn more about how we build Springfield, we first point you to resources on Azure, how you can use Azure Resource Manager to create resources, virtual machine, network interfaces in Azure, how you can use network security group to secure your network in Azure. Also, we built the entire service using F#. We have a blog post where we talk about how we did that. So if you're interested in that, you can look at this. And also there's this website where you can learn how to use F# called tryfsharp.org.
And if you're interested more in Sage or in white box fuzzing technologies, there are many papers, like I said, over a decade of research that you can read up on. The link we provided is a more general overview that then has a lot of other fun resources that you can learn about. And you can also, if you're curious about Z3, or you may have uses for Z3, there's a nice introductory Channel 9 video that was done a few years ago that you can check out.
All right. I think that's all we have for today. Thank you all for watching.
Thanks very much, and have a great Build 2017.